we should be going live just a second.
Okay.
Yes.
Okay, Molly tells me we're live now. All right. Welcome to the November meeting for the Cascade Mycological Society. Tonight's invited speaker is Thea Chesney from the U.S. Forest Service in California. Thea, welcome. And Thea Chesney's a botanist with, like I said, with the Forest Service in California. And I'll read what we have on our website. Thea Chesney is a lifelong Sierra Nevada foothill resident and naturalist. Her childhood interest is in local mushrooms, wildlife, and flora has transformed into an unending devotion to the natural world. Thea earned her BS in forestry from the UC Berkeley while pursuing her passion for fungal taxonomy in the Berkeley Mycology Labs, and since then has spent her time exploring the California mountains and the organisms that call them home. She currently works for the Forest Service as a seasonal botanist on a long-term statewide meadow monitoring project. Woohoo, what a great job. She continues to be particularly fascinated by the plants and the fungi of the Sierra Nevada and other mountains of California, and is currently working on a field guide to the mushrooms of these understudied regions. And Thea, welcome.
Chris, I think we lost Thea.
Okay.
Hopefully we'll get her back in just a minute. You want to say something about the festival?
Sure. I wanted to extend a thank you to all the volunteers who made the Mount Pisgah Arboretum Mushroom Festival a success. The Lane Community College students and Susie Holmes, the instructor there, Ron Hamill, the chief identifier and mycologist for the festival, my lovely wife, Molly Widmer, and every single person who helped collect on the multiple collection forays, everybody who staffed the event on the day of the show, and everybody who participated in the Myco Blitz on iNaturalist. We had nearly 400, I think we had 390 identified species on display, and something in the neighborhood of 485 species identified on iNaturalist. And thanks to Noah Siegel, Thea's co-author on the upcoming mushrooms of the Sierra Nevadas, for his help on iNaturalist. So we do have Thea back. She's here live via Zoom from California. Thea, welcome.
Thank you. I hope that other folks are online. I don't see anybody else's participants yet, but I'm very glad to be joining you, and happy to share something that's really close to my heart, and talking about fungi and fire and our connections to all of those. So if hopefully we're live, and I can start sharing my screen.
All right. Thank you, Thea. I'll check out here and we'll talk to you at the end.
Sounds good. Perfect. Well, welcome everybody. Thank you, Chris, and thank you, Sandy, for the invitation. I'm very happy to be sharing my some of my research and just synthesizing others' research with you guys tonight. And I'll be talking about fire and fungi in Western forests. Be talking a little bit about the history of fire and where we are now in our situation with fire, and what might be next for us all. So this necessarily includes some information about plants, because we can't talk about fungi without talking about plants. And fire ecology also makes more sense when we are talking about multiple kingdoms of organisms, because it's not just plants, it's not just fungi, it's actually not just plants and fungi together, it's all kingdoms of organisms which are affected greatly by fire. And the communities of all these different kingdoms of beings also have a profound effect on the way fire behaves. So I wanted to kind of talk about some of the ways in which I approach this issue. First of all, in my day job, I'm a botanist with the US Forest Service, and I work in a long-term wetland and meadow monitoring project. So I have spent a lot of time in the field, always in California. And I've seen, therefore, a lot of forests which have burned, a lot of forests before they burned, and I spend a lot of time just hanging around in meadows, which is pretty cool. But I'm also a lifelong Californian, and I've seen not just our national forests and how they're being shaped by fire right now, but also communities closer to my home and to my heart, which have experienced, quite frankly, catastrophic fire. So I want to acknowledge that wildfire is a touchy subject. It can be a really difficult thing to talk about for people who have been directly affected, for those who've had to flee their homes from fire, for those who've lost communities, who may have lost friends, for those who work in firefighting and have had really stressful experiences, and just for those like me who've seen pretty dramatic change in some of our favorite places. And I'm sure that that's true for you up in Oregon as well. And I'll be talking a little bit about the mega fires that are happening today and how they interact with fungi. So this is kind of going to be my place to tell you that most of my information is from California, because that's where I live, that's where I work. But I did a lot of reading about what's going on in Oregon in preparation for this talk, and I'll be happy to take questions about, things that you might have specific information on, specific fires. And if I don't know, I'll make something up and make it sound good. So a little bit of an outline here, got a little bit of information about fire history, and this is true both Oregon and California, and our climate and how our climate's changing and how that has an effect on fire. And also a little teeny bit about our history of fire management from indigenous peoples to current day. And we'll go into a little bit more about ecology. Yes, I will be mentioning plants as well as fungi, and talking about kind of community ecology there. And then I'll talk a little bit about fungi which specifically follow fire, and bring some examples of those in, and talk about perhaps most people's favorite fire-following fungi, Morels. We'll talk a little bit about what we're looking towards in the future. So here's a very California-specific slide, but it gets at some of the terminology that I'll be using and talking about fire regimes. And a fire regime simply means that it refers to the frequency, intensity, and pattern of wildfires that prevail in an area. And so fire regimes can change over time, and they absolutely have changed over time. In California, in many California ecosystems, not all, but many, including our classic mixed conifer forests and our oak woodlands, the historic fire regime was very frequent, very low severity fires. And the sources of those, primarily people and lightning, and more lightning as you move upslope in the mountains. And I know this is true in the Cascades too. You don't have lightning as a primary source of fire in the lowlands, but when you get towards the Cascade Crest, absolutely. And so primarily what we see in the historical record, not now, was that a lot of Western ecosystems, especially those east of the Cascade Crest and from the Great Central Valley east in California, were fuel limited. That means that fire spread was limited by the amount of fuel on the ground. So there just wasn't much fuel around. And if you've walked around pretty much anywhere in Oregon, Washington, or California recently, I think you can say pretty safely that most ecosystems are not in that state anymore. And something else that's very specific to California, but I know that many of you may have visited the coast redwood forests, and probably like your coastal wet temperate rainforest areas in Oregon and Washington as well, you know, you think of redwoods as being in pretty wet areas and certainly getting fog drip in the summertime to keep them moist. But all of these new numbers here, these intervals, are historically years between fires. And this was done through tree ring and fire scar studies in these redwood forests. So you get a frequency that we're looking at maybe an average of 8 years between fire in the north. And you get, you know, there's different areas that have different kind of ranges, but they're all fairly frequent. And so this is something that was eye-opening for me, and as somebody who's spent a lot of time walking around in redwood forests, is that you see the old fire scars in some of the old stumps and some of the older trees. So you know that these places must have burned, but it's still kind of hard to wrap the mind around some place that seems so wet and so lush, burning so regularly, because they certainly haven't burned so regularly any time in living memory. So how and why? It's somewhat of an open question in some places. We do know that Indigenous people had a lot to do with fire in these ecosystems, but I highly recommend looking at both of these papers. I think both are freely available. So this presentation will be available, and I highly encourage you to check these out. Continuing on with more California specific stuff, and I know Oregon shares a lot of this history too, perhaps not such large scale mining operations, but grazing and logging, the two primary means of landscape alteration, have been equally important in both states. And the timelines might be a little different between our states, but absolutely kind of similar. Since Native people are such a huge part of the fire regime, that the forced removal and killing of so many tribes really had detrimental effects on the land, obviously on the people, but also on the landscape, just because they were the ones who traditionally managed these places. And with Native people gone, a lot of the memory of how the land had been for thousands of years, a lot of the memory of processes that happen over a long time scale was lost. However, in early years of settlement by white people in Western North America, we're pretty good about altering the landscape pretty quickly, but not so great at suppressing wildfire. And so in the earlier period of settlement, there were still some large wildfires, absolutely. But then once you get into the 1920s and 1930s, this is kind of where the development of modern firefighting kind of happened, and you get into much more effective fire suppression, at least most of the time. And this pattern, I think, holds true across the West, but certainly it's true in California, that we have less acreage burned than probably historically was burning, but more of it, especially in the last 20 years, in the last 10 years, and the last 5 years, is being burned in these large, really high severity fire events. And if you've walked around in the woods at all, you probably have noticed that there's a lot of fuel out there. And in most cases, it's pretty dry, at least some of the year. And I'm envious of those of you who live further north, getting to explore your wetter coastal forests more regularly. But down where I live, we're quite often in really droughty conditions. I will say here, I'm talking more about an ignition limited fire regime, meaning that there's plenty of fuel. Things will burn whenever the conditions are right. So whenever there's an ignition there may be a fire, which wouldn't have been the case historically in a lot of these ecosystems. Here's a forest close to my house that's being managed now again with frequent prescribed fire. And you can see kind of how open it is. There's a lot of ponderosa pine in here. There's some Douglas fir, there's some white fir. But this kind of forest is really hard to find these days. And a lot of forests that I've walked around in, both in the Western Cascades and west slope of the Sierra Nevada and the east slope of the Sierra Nevada, look a lot more like this. And I was actually trying to take a picture of the radio collared deer in the middle of this photo, and it's kind of blurry, but it's a mess. You can't walk through that. There's downwood everywhere. You can't see through the forest very far at all. And that is so typical. It's a little less true on the east side, but I'm going to show you a picture of the east side of the Sierra Nevada in California that's not very open anymore either. So as you can see here, there's just a ton of fuel on the ground. Things are ready to burn. So in order to think about how fungi and plants interact with fire, we need to think about what fire is physically doing. So this is, of course, dependent upon the severity of the fire. If it's a high severity fire, these effects are going to be a lot more drastic. And if it's a low severity fire, things might not change so much. But fire always involves soil heating. It's going to consume some organic matter. You're going to see somewhat of a pH shift to a higher pH, and also a release of nutrients from ash deposition. And we're going to see some mortality, again, very dependent on the severity of some plants, fungi, bacteria, slime molds, insects, mammals, any kind of organism. And as a result of some of this organism death, we're also going to see some increased water availability. And in a high severity fire, that increased water availability can be really obvious and turn a slight seep or a damp area into heavy flowing water, which is kind of magical in one way. But it also means a pretty drastic change in the landscape. So we're thinking about plants and fire. We have some pretty well-known survival strategies, and I'm not going to spend too much time on them. But if you've looked at a ponderosa pine or a redwood or a Douglas fir, you've probably noticed that they have really thick bark, and this is a fire resistance strategy. Also, a lot of these trees do kind of self-prune to raise the height to their lowest branches. A lot of trees, like many oaks, have resprouting as a strategy where they can be top-tilled, but they'll come right back. And some species of plants, including some pines, have developed serotiny, where their cones don't open until they are burned, or have some other kind of fire-stimulated seed germination. I promise I'm getting to mushrooms. But first, a little bit more about plants. So I said I would show you some pictures of ecosystems that would have been dependent on fire historically and still would be better off with a bit of fire. This is a meadow on the Tahoe National Forest, and it's on the east side, which means that it's primarily Jeffrey pine forest around there. And as you can see, this is a very dense Jeffrey pine forest, and you have a lot of encroachment of young trees into the meadow. And this is a condition that's really common all over the Cascade area and the Sierra Nevada. So ponderosa pine, as I talked about, is one of those superbly well fire adapted trees to low severity fire with its really thick bark, and also likes to germinate in open spaces and bare soil. But as you probably know, you've probably seen ponderosa pine, Jeffrey pine, and in areas where there are a few mature trees and then a whole lot of shade tolerant undergrowth, a lot more Doug fir, in California and Southern Oregon, a lot more incense cedar, a lot more white fir, sometimes grand fir. And so that's something that's really changed. Our forest structure has really changed, and the species composition in terms of plants have changed. So of course, if you're thinking about ectomycorrhizal fungi, yes, things have very much changed. Just had to throw in a little shot of oak woodlands as well, because while they're different oaks, I know of a lot of beautiful oak woodland settings in Oregon as well. And I was reading about also the history of the Willamette Valley. And of course, that's the most densely populated part of Oregon now, but also had, of course, historic oak woodlands and Douglas fir and a mix of trees. And I was reading a little bit about indigenous folks burning. So a lot of oak woodland ecosystems had surface fire, low severity fire, historically very frequently through them. And this is an ecosystem that's near and dear to my heart, because this is where I live in the oak woodlands of California. And it's definitely all over the West Coast, one of the ecosystems that's been the hardest hit by development. And where there's open land, it's typically under pretty heavy grazing pressure, which does help to reduce fire danger, but it also isn't so great for regeneration of oaks or for kind of soil conditions, which of course also has an effect on our fungi. And now for a landscape that does not look like this anymore, because this was taken in May of 2020, and this is in the Mendocino National Forest, shortly before the August complex fire of 2020 burned most of these ridges. So it was, and will be again, is still a very diverse landscape. You have, prairies, oaks, Douglas fir, redwoods, a whole bunch of tree diversity here. But I will also say that I haven't been back there yet. And it's going to be a little hard for me to go back, but I'm also looking forward to seeing how it looks now. So on to the fungi, which is why we're all here, right? So talked a little bit about plant adaptations to fire. So what about fungal adaptations to fire? So we talked a little bit about kind of resistant structures in plants, whether that's thick bark or roots that are resistant and can survive fire even if the top of the tree is killed. Well, fungi have resistant stages as well. A lot of fire-following fungi and others will form sclerotia, which is basically a resting stage before the fruit body is produced. So the fungus will just kind of gather nutrients, gather everything, and then just have this storage organ. And a lot of sclerotia are resistant to fire. Another strategy is thick-walled spores, and I will show you an example of thick-walled spores here in a minute. Many fungi have dark spores, and yes, that is because of the presence of melanin. For those of you who may not be aware, yes, fungi have a lot of the same pathways as animals do, producing pigments, some of the same pigments that are sun protective. Also, fungi that can follow fire are often able to step up their processing of nutrients, step up their nitrogen processing in particular, and phosphorus as well. So this can take advantage of the release of nutrients from ash deposition after fire. And then we have interesting research that's still waiting to be done on fungi which shift their nutritional mode or produce fruiting bodies upon the death of their plant host. And this is something that has a lot to do with fungi that are endophytes that spend part of their life cycle living within plant tissue. And just as there are exceptions to the plant adaptations to fire, there are also adaptations that fungi that do not have any of these adaptations, at least not that we know of. So there are exceptions to all of these rules. So here's what I'm talking about with those thick-walled spores. And maybe it's not dramatic if you haven't spent a whole lot of time looking at fungal spores, but to me, this is very dramatic with these dark walls that you can see around the outside of these dark pigmented spores. And I want to thank Fred Stevens so much for graciously putting his microscopic photographs on the internet, because I don't have the patience to do too much of this. So thanks, Fred. But yeah, these are the spores of a little brown guild mushroom that fruits almost exclusively after fire. And you can see, you can kind of see its strategy here. Those spores will make it through a lot of things. So yes, there are fungi that follow fire specifically, and it kind of makes sense that some of them are going to be mycorrhizal, are going to be associated with living plants. Others, as I hinted at before, might be endophytes, or they might be living within a plant tissue, and others might be litter decomposers, or some might even switch their nutritional strategy at the point of fire, shortly after fire. So I'm going to talk about a mycorrhizal example here, and this is something that Tom Bruns' lab at UC Berkeley did a lot of research on. And Rhizopogon olivaceo-tinctus, really associated with bishop pine, so something in coastal California that's quite common. So this Rhizopogon, it's a false truffle. If you know, when you have a fruit body of it, it'll be growing underground. It'll be a little potato kind of thing. A lot of the research, what's happened? Why can't we find this fungus? Why isn't it fruiting? And yes, truffles and false truffles can be hard to find in general, but also in studies of rodent scat, and rodents are the primary consumers of these false truffles, the spores of this species just didn't show up, even though the spores are present in the soil spore bank. And then after fire, when you have all these new little bishop pine seedlings starting, this fungus just appears everywhere on the root tips. But you have to look at the root tips because it's not forming fruiting bodies. So it is definitely an enigmatic little guy. But this is what the Bruns lab did. And they looked at bishop pine seedlings that they had grown in the greenhouse and inoculated them with Rhizopogon olivaceo-tinctus spores, and they compared those spores that had not been heated, and then they also heated some spores to simulate fire. They did a number of different kind of soil heating treatments, and they found that there was this huge difference in colonization of the roots of these little pine seedlings after the spores had been heated. So it's something that very clearly is responding to fire and is taking advantage of that niche, with bishop pine being a rapid reseeder after fire, having somewhat serotinous cones, and just taking advantage of all that bare soil to germinate right away. And the fungus is there already, and having been stimulated by fire can just colonize those root tips right away, and therefore make the bishop pine seedlings a lot more successful. And obviously it's a success story for the fungus as well. And then it seems to disappear within a few years after these pine seedlings have gotten established, and you don't see the fungus again until there's another fire. So that's a pretty interesting and pretty unique situation here. But it's just one species. And we know that mycorrhizal communities in forests are hugely complicated. There are hundreds of species involved, Some of them don't form fruiting bodies that we can see easily. Some of them do. But the strategy that I just illustrated of Rhizopogon olivaceo-tinctus is not universal, of course not. So some mycorrhizal species do that. They'll recolonize very quickly after a fire. Others don't do well if their tree hosts are killed off. And so they're the ones that are adapted to more low severity fire, like those on ponderosa pine, those on oak roots, probably are tolerant of some heating, but not too much. And so they'll survive if their tree host survives, hopefully. So there's all these different strategies that you can see among different species. And I want to highlight that we don't know that much about individual strategies of mycorrhizal species. So, this is ongoing research. I'm not doing any of that myself, but I am very glad that there are other people out there doing that. And now knowing that we have that kind of different fungal species responding differently to different levels of fire severity, we can think about how our fungal communities have changed and how they're continuing to change with changes in our fire regime. And I want to emphasize that we have a lot of questions to answer. I don't have the answers here, but this is something that collectively we're going to be finding out more about, whether we want to or not, because of the way we're seeing fires play out on the landscape now. So I've hinted about this before, but we do have a specific suite of fungi, which are fire followers, full stop. And this group of fungi is not a taxonomic group. It's not composed of things that are closely related to one another, but it's an ecological niche. And this was first recognized in the literature in Europe in about 1950, 1949, I think was the first mention of it, by Meinhard Moser. And yes, there are fungi in Europe, there are fungi in Asia, there are fungi in North America, and all over the world. Some very widespread species, which you'll only find in burned areas, recently burned areas, and sometimes can be like a campfire ring or even a fireplace. And you'll sometimes hear them called fireplace fungi or see that in European texts in particular. You get pyrophilous fungi is a term that I like to use. You'll also hear carboniculus, anthrocophilus, and those may sound like funky long words, but you'll see them in the species names of these mushrooms. They're so adapted to that. They're adapted to the sterilization and heating of their substrate, whether that's wood, soil. They're adapted to dealing with this nutrient flush, adapted to removal of competition from other species, removal of litter and duff from the environment, and as I say, plant mortality, so reduction of potential hosts or potential competitors. And now we get to actual mushroom pictures, or I don't know, it'd be a stretch to call this one particularly a mushroom. So this is a Pyronema. This group of little crust-like fungi, it's usually one of the first groups of fungi you see after fire. And yeah, this one was after a wildfire, then next year's salvage logging and pile burning. But the last time I saw this species was last week, or species in this group. And it was not in a wildfire area. It was on an area that had been treated by thinning, and then the debris from the thinning was piled in and burned on site there. And so the fire, in this case, it was lit in October, right around the time that the rains got going. And so the piles were there, they'd been burned. They're still putting out just a little teeny bit of heat, and this fungus is already popping up in them in November. So it's a pretty quick responder. and can be seen fall or spring, or even winter in places with milder climates. This is not my photo, this is Damon Teig. Some of you may know, a very intrepid mushroomer and brilliant scientist based in the Bay Area. And so he went out on the Sonoma coast after some of the fires there in 2020 and documented some of the other really common fire-following fungi. So Geocypha or Pisiza violacea, and there's a species complex of purple Pisizas that fruit after fire. So do with that information what you will. And then these little, much smaller orange cups surrounding them that are Anthocobia of some kind. And in a lot of places, you'll just see these coating the ground, absolutely coating the ground, or at least big patches of burned ground after a fire. And this, as you can see from the foliage, was in a redwood forest on the Sonoma coast. Back to one of my finds here. I documented this primarily because it was an odd time of year to find it. This was the 1st of September in 2020. And this was after a prescribed fire the previous year. And I like to say, well, it was an odd fruiting, but then 2020 was an odd year. And a lot of these fire-following fungi really are opportunistic fruiters. They can fruit whenever there's enough moisture and the conditions are right after the burns come through. So I'm going to give a little bit of local context here. The Caples fire was a prescribed fire in 2019 on the El Dorado National Forest in California, and it got a little bit bigger than the fire managers wanted it to. It kind of went out of prescription, although it was never really out of control, and it burned about 3,000 acres. And it burned some meadows, it burned some forest with mature trees, but it was actually, despite going out of prescription, a really nicely behaved prescribed fire in that it stayed as a low severity burn, and most of the mature trees made it through, no problem. So, success story on that front, and that's relevant to this year because the much larger Caldor fire, which I'm sure some of you heard about on the news, went through the same area of the El Dorado National Forest, but it pretty much avoided the perimeter of the Caples fire, or stopped against the border of the Caples fire. So that's something that's saying to me, and I think to fire managers, is that we need a lot more prescribed fire like the Caples fire, even stuff that's, maybe going a little bit more than we want it to. Maybe it's going a little bit crazy, but it's a lot better to have that kind of burn under more mild conditions than it is to have something like the Caldor fire that just burns through half an entire forest in the space of a few days when conditions are really, really dry. And so that's something that I hope is taken to heart by those who actually make decisions about ways to manage our lands. And I don't know what you're seeing in terms of prescribed fire in Oregon, but I hope that lessons are being learned there as well. Go back to the last big fire on the same national forest, the El Dorado National Forest, the King Fire in 2014. So I did a lot of mushroom hunting around that whole area after that fire. And this is kind of an example of a little community. And I don't know how many species each of you can see in there, but I count 3 that I could make out with my eyes. And one of them, of course, are Morels, Morchella of some kind. Then there's the little brown gilled one that I showed you the spores of earlier, Crassosporium, Funerariophyllum. And then there's those little cups, like I showed you just in the previous photograph, the Geopixus carbonaria. So often when fire-following fungi are fruiting after a fire, you're not just going to see one, you're going to see a community of at least 2 or 3, maybe more species around the landscape, because when conditions are good for one, they're usually good for multiple species. I noticed that I hedged here on the Morchella ID because, as some of you probably know quite well, fire-following Morels can be excruciatingly difficult or impossible to get to species. There's some that are more distinctive, of course, but there are those like these, which are not distinctive at all, but they taste good. So there's that. Here's another group of burned morels that continued to fruit 2 years after the fire. So a lot of these fire-following fungi, and yes, for those of you who are out looking for morels do this. It's not just the year directly after the fire or the spring directly after a fall fire in which you can find these fire-specific mushroom species. You can often find them lingering into 2 and 3 years after burn, but declining in frequency and being replaced more by mushroom species that are not so tolerant of fire. So that's an interesting kind of succession to watch if you have the privilege of checking out an area, in the spring and fall, and just seeing how things change, both directly, immediately after fire, and then in the years after that. And just wanted to also show a guild mushroom. It's a little bit meatier. This is a foliota, and we have several different foliotas that look kind of similar to this, with slimy caps and finely scaly stipes. Some of these foliotas absolutely are fire dependent. This one's a chunkier one that grows at lower elevations in California, but there's a smaller version, Foliota highlandensis, that is really common in montane forests of the West after fire. So be on the lookout for those. And then here's one of Christian Schwartz's photographs from Big Basin State Park in California in the Redwoods. And it's of this funky cauliflowery thing that is often a rather large fruiting body and seems to only come up after fire. And this observation from February of 21, I went on to iNaturalist and took a look at observations of this species. And there are 44 observations currently on iNaturalist, and 31 of them were made in 2021 after fires in 2020. And most of them are in Oregon and California. So this is something that is probably fairly specific to the West Coast, to Western montane forests, but also occurs down into Southern California, which I don't think you could call a montane forest by any stretch of the imagination. So it's a really interesting thing. And, sometimes it gets misidentified as a sporassis, as a cauliflower mushroom, but the seasonality is different. And the fact that you're finding it in a burned area should give you a clue that you're looking at something a little different. This is one of those fungi that's an oddball, and it seems like it's been overlooked for years, but perhaps that's because we weren't tuned into it, because it wasn't that common, because we weren't seeing a lot of our forests burn. And perhaps it's just something that we've collectively learned more about for other reasons. But I'll be interested to see how our observations of this particular species of mushroom continue to change over the years. And I want to see how closely that tracks with our fire years. I think, platforms like iNaturalist offer a lot of possibilities for future research because of things like this, species that we may not know about, and then people start to find them and word gets out and more people start to find them, more people start to recognize it. And then all of a sudden we end up with a large number of observations, and we can start to look at trends, right? People seeing these more in areas that have burned within the last year. Are Are they different in different parts of their ranges? Do they look different? Are we seeing different population structures emerge? So this is my plug for iNaturalist. Please use it to document what you're finding. You don't have to document your prized edibles, but document weird stuff like this and also common stuff, and see where it gets us collectively. So as cool as the fungi after fire can be, this is a little bit more back to earth, back to reality. And I mentioned prescribed burning. I mentioned that we are seeing larger and larger fires, as I'm sure all of you are only too aware of. So, what can we do? And sometimes, like, as individuals, it doesn't feel like we can do much at all other than watch things burn and hope our houses aren't next. But I hope that we can advocate to people who actually have the power to make these land management decisions, be proactive. We're going to see these lands burn one way or another. So we should probably be trying to see them burn under better conditions. That means prescribed burning. Now, this doesn't necessarily mean that prescribed burning is going to be great for every plant species. It certainly doesn't mean it's going to be great for every mushroom species. And that brings up kind of another line of thinking that sometimes bogs me down. And that is, the fungi we are seeing today, the diversity of fungi that we have observed, that we enjoy going out into the woods to find, our stunning array of, just pick a group, waxy caps. They're one of my favorite groups. Like, it's hard to know how abundant these species were historically. And it makes a certain amount of logical sense that some of these groups of fungi, which we may think of as common now, were not common under a more frequent fire regime. But it's hard to say. It's really, we can't reconstruct the way the forests used to be. Or maybe we can try, we might have an idea of what the forest structure looks like, but that doesn't mean we know anything about what the fungi were historically like. And so when fungi are accounted for in land management talks, which is not frequently enough, it can be hard to know what to say as an ecologist, thinking about how different landscape treatments, thinning, burning, anything might impact populations of fungi. And I wish I had answers here, but this is something that I'm really curious about and also very depressed by, is that we may have lost stuff without knowing it. In fact, we probably did lose species without knowing it. But the cost of our inaction now might be to lose even more. But the cost of action can also be to lose some more species. So it's not a reason to stand still and do nothing, but it is a very good reason to do some monitoring. And this is my bread and butter. This is what I do for a living, not monitoring mushrooms, but monitoring plants, yes. If we don't know what's out there now, we aren't going to be able to recognize when it changes. So, as I said, please use iNaturalist. Please get out there, document what you're seeing before your patch burns up, and then document after, if you can stand it, if you can stand to be there. And that's the only way that we're going to be able to answer these questions in the future, is just by gathering data now. And it'll be very, very interesting to see how fungi are changing in a changing climate with changing fire regimes, fire behavior. But I don't know, I'm along for the ride, and I hope you are too. So with that, I'd like to open it up for questions.
Thank you, Thea. That was amazing, and lots of information there, and a lot of heartfelt feelings there about fire and climate change. And great plug for the citizen science that's going on around iNaturalist. Sandy, do we have questions from the audience for Thea?
I'm waiting for them to come in. There's a little bit of a time lag.
Okay.
I have a question, because I would think that you monitor plants, and I would think that we would have a lot better record of plants over time than we have.
This is true
for mushrooms.
Mm-hmm.
So I would think that there, and I also want to mention that at our festival, Ron Hamill, who can tell Chris if you know him, he brought in lots of fungi from after a fire that unfortunately his house burned in, but he's been monitoring that area for years, and then it burned. That was the Archie Creek fire, and it was really interesting to have those fungi on the table. But I just wondered if you could speak to plants as far as what you know as far as the changes.
Sure, about how they've responded to fire. And
well, I guess you probably talked about that. I mean, as far as any disappearing that we know of, or
sure. Yes, when we think about rare plants, some of them are absolutely threatened by changing fire regimes, but most of what I'm concerned about here in this talk are, the trees with which our beloved fungi are associated. So things like ponderous pine, Douglas fir, and certainly have different concerns up north than I do here in California, but I really am seeing a large scale shift in where our conifer forests are. And I didn't even get into mentioning during my talk, like high elevation forests, which typically would have had infrequent fire, primarily caused by lightning. But those are the places that I think are suffering most from our changing climate, whether or not fire has hit them yet. It will. But our species like white bark pine, like mountain hemlock, they're the ones that are most at risk of disappearing. And also trees about whose fungi we know very little. So that's both a really fascinating area and a terrifying area for me. Bristlecone pine, limber pine, these high elevation ecosystems that in many ways are a lot more fragile than the kind of mixed conifer and especially west slope kind of habitats that we spend most of our time hunting mushrooms in.
Thea, could you quit sharing your screen so we can see you?
Yes.
And
good suggestion, Chris. Actually, we have several questions coming in now. First one is from Grace Pugh. All right, Grace. Can we use spores in soil or other layers to discover species that may already have gone extinct? Are you aware of any research in that?
I'm not aware of the exact research that's being done. I do know that there are people who are approaching that question, and a lot of it is trickier just because we're still about 200 years behind botany in terms of what we know. But there are historical cores of, say, lakebed sediment that are getting at, you know, ancient pollen concentrations of different plant species that may or may not exist in an area anymore. And pollen is really easy to, if you're trained in it, to get at least to groups of species morphologically. And you can, to some extent, do that with fungal spores, but it's harder, especially if we're talking about ancient sediments where tissues might not be preserved that well. But I see that as a distinct possibility, and I hope that I get to know more about research that's going on in that way. And in terms of the soil spore bank, it's usually not such a long time scale, although it still could be really, really helpful to know what's out there. So that's something that's like on the 50 to 100-year time scale. There could still be spores out there that would be identifiable and maybe even viable, but the conditions just haven't been right yet. But beyond that, which is already, we're talking a very altered fire regime by 100 years ago, very altered landscape. Pretty hard to get at, but it's a great question.
Okay, questions are piling up here. Okay, so do fire-following fungi, which has spores that require fire to spawn?
Yeah, to germinate.
Food,
yeah, absolutely.
To germinate, right. Do they have a more extensive mycelium network between fires?
Also a really good question. I don't know the answer to that. And I don't know any reason why they would have a more extensive mycelial network. In fact, I think it might be the exact opposite, that they don't do very well as competitors when there's not disturbance happening. They're more taking advantage of conditions immediately after a fire to get themselves established when there's not much competition. So yeah, I would say that I don't know for sure, but that's probably, I would lean towards the opposite of that being true.
Okay, I think I have a two-part question from Dylan. Are fire-associated species similar amongst different continents, or are they locally specific? Additionally, are East Coast species similar to West Coast, or are they genetically distinct?
That's a great question. And with some fire-following species, they do seem to be fairly cosmopolitan. We think we're seeing the same species in Australia and New Zealand as we are in Europe, as we are in California, as we are in New York. But others are certainly different, like the Morchella, for instance. As some of you probably are aware, the number of species of Morchella that we've seen have the number of species has just exploded with somewhat recent research, and it'll continue to grow. And I don't actually know of fire-associated morels being a phenomenon that occurs, at least in numbers, away from Western North America. So that's a fairly localized thing. And I think that there are some species that are absolutely local and specific, where others are more cosmopolitan.
Oops, okay. So we actually have someone, this isn't really a question. We have someone that's tuning in from Flagstaff, Arizona, and listening and watching. And they want to be in touch with people who are working in the area of protecting fungal diversity through severe burns and thinning. And, wants to know a contact. Would that be just the Forest Service or anyone specific?
Yeah, if you want to know what's happening on public lands that are of concern to you, you need to contact whoever is managing those public lands, whether it's the Forest Service, BLM, Park Service, whoever's involved, and just like hopefully your local front desk person will be able to connect you with somebody who knows more about what's going on. But also in the planning stages, all of these treatments, thinning, prescribed burning, you know, there is some provision for public notification and public comment. So definitely recommend following your local district or your local national forest or your local BLM district, whoever is the primary land manager, to get an idea of what they've got planned, what they've got coming, and to, yeah, be able to voice your concerns.
Okay, here's the next question is from Nathan. What's the role of plant diversity in landscape management? I assume as it pertains to fire.
Yeah, so plant diversity, landscape management, most of my experience, as I said, is in California, but what we're, you know, thinking about are different ecosystems, saying, and then in some ways some of our ecosystems have become less diverse because of fire suppression, and plant diversity has just changed. A lot of rare plant species and species of concern in California are actually those that require open canopies or disturbance on a regular basis to reduce competition. So there are some plants in California where it's actually pretty funny on some level, because there's this rare cypress. A lot of cypress species are really fire adapted, and in which they burned, all of the cypress burned, but then there's this just absolute carpet of seedlings post fire. So that's a very specific habitat. But the diversity is being preserved in this case by a fire coming through. So it's a complicated question. There are all sorts of kinds of all sorts of questions with different kinds of plant diversity and different fire regimes, but yes, absolutely. What you'd expect to see in a certain kind of ecosystem dominated by certain plants with one fire regime is completely different from what you'd expect to see, say, in a coastal pine scrub situation, different from a chaparral situation, different from a mixed conifer forest. So yeah, that's kind of open invitation.
Okay, let me see. Oh, what's it, Rob? Just a second. Let me scroll down. Okay, so this is from Adam. He says he's read that Native people in Eugene area here would like to use controlled fire. Would use controlled fire to help production of camas lily, an important food source. So maybe that's in the past. Are there other examples of Native peoples using fire in this manner? And would they have been aware of fire-following mushrooms as a food source?
Yes, is probably the answer to those. So yeah, in California, there are a lot of examples in many, if not most, tribal histories of burning for food production and also for basketry material production to increase the quality thereof. Yeah, camas lily is a huge thing. Other bulbs, other geophytes definitely benefit from fire, and also in a lot of ecosystems, oaks benefit from fire because keeping the conifer competition down encourages oaks. And if acorns are your primary food source, which is the case for a lot of tribes in California and in Oregon too, I'm sure, yeah, you want to be burning for your oaks so that you have a good acorn crop. Reducing pests is another thing. Reducing pests in the acorn crop fire is really helpful for that.
I might interject here, Thea, that you had that one slide of fire return intervals in coastal redwood forests being ridiculously short.
Mhm.
Suggest that those were burns initiated by indigenous folks.
Absolutely.
And so one of the things, and I've learned over the years as you have, once you look into the depth of any ecosystem, that indigenous management had a real impact on what pre-settlement environments looked like.
Mhm.
And I think that where we see fire return intervals and those short time frames in such a moist environment, you know, the only really logical result is that it is anthropogenic fire.
Yeah, absolutely. So yeah, that's a really good point, and something that I would hope people realize is the absolute anthropogenic nature of historical burn patterns in probably a lot of Western North America. It was funny because I was looking at fire history studies and trying to piece together information regarding Oregon and Washington and British Columbia, and I was having a really hard time. There's so much more research that's been done in California than has been done in the Pacific Northwest on some of these topics. So I was able to find a couple of things specific to Central Oregon, east of the Cascades, but yeah, I mean, there's so much out there that we just don't know. That's something that certainly keeps me interested.
True that. Thank you. Sandy, back to you.
I'm not seeing any more questions. I'm seeing lots of compliments on your talk. A lot of people enjoy it right now. We had up to 70 people, I think. We're at 60 now.
Nice. So I have a question, Thea, on that Daleomyces, if I'm pronouncing that correctly. I think what you were suggesting is that it might have been endophytic, or I'm not sure what the exact term is for fungi that are endos within a plant. But
yeah, endophytes. So endophyte just means anything that's living within plant tissues. Yeah.
Okay. So is that species a confirmed endophyte, or is that still theoretical? You know?
As far as I know, it's theoretical. That's a very interesting question, and I kind of assume that that's the way it is, but I'm not sure at all what its life history is.
To me, it's really a phenomenally fascinating fungal life history. And when you find out that one of the fungal species on the Forest Service survey and managed lists back in the old days was perennial polypore, Bridgeopore, Boxioporus. And I think the research has found that it was also an endophyte, and then only expressed a fruit body after its host was dead. So I think what we're seeing there is something that's a long-lived endophyte that's really only fruits in a natural situation where the individual dies, and this Daleomyces is instead maybe not such an individual host thing, but maybe across the forest system and in a lot more places. And now that we have, you know, citizen science being such a big component.
I think I lost you there because I lost your audio, but yeah.
We do have a couple more questions.
Okay.
Oh, it's not good when well, I'm a computer person. A lot of times when I get these questions, it's like, is that a word? Do I know what that word means? So I always learn something. Okay. So a question from the person who is from Arizona. Any work on creating fire protected refugia. That's a new word to me. I just looked it up. Via which forests could be artificially reseeded, respored over time.
So yeah, refugium or refugia, it does literally mean a refuge. And so climate refugia would be, places that would be protected and could then be a seed source, a mycelium source, a spore source for future restoration efforts. But that assumes that that area truly is protected. And it's a complicated sort of ask, I think, because some of our species that we care about are so, disturbance dependent. Others really are not. And we just don't have enough of an understanding of the whole fungal community to, I think, make such an effort happen. I mean, in some ways it's a great idea, but I don't know how realistic it is.
Okay, let me see. Okay, from Heather Kent. Are you aware of anyone looking at the difference in fungal communities after logging in plots where biochar programs are being implemented versus regular slash burning?
Very interesting question. And no, I don't know of anybody doing that research, but I hope there's research being done. So for those who may not be aware, biochar application is somewhat of an active topic of research, and just means applying charcoal that's usually been burned off-site to the surface. And that's a really interesting question about how that would shape response of fungi versus burning slash on site in piles or broadcast burning. Yeah, I'd love to see that research. I just don't know who's doing it. That'd be interesting because I don't think you'd see all of the same effects because you don't have the soil heating component. What you are getting is kind of the nutrient addition from the ash, from the charcoal, but it's not the same as having had fire on site. But that's a really interesting question.
Okay, next question is, let me see. Oh, has there been any genomic confirmation of the cosmopolitan nature of fire-following fungi, or are observations so far mainly morphological? So genomic versus morphological.
Yeah. I am probably the wrong person to ask about this, but I don't know of any genomic studies that have been done comparing collections of these fire-following fungi from different parts of the world. It seems like some would have been done, but yeah, I'm sure there are other people who would be able to answer that much better than me.
Still reading here. Okay, I don't think these other things I'm reading are questions. I think it's just people chatting to each other. Is Chris back?
I'm here. I did have one sort of thought when people, I think the questioner from the Southwest was asking about restoration and refugia and fungi used for restoration and sorts of questions around that. And what I started to think of was with plants, especially agricultural focused, we have a repository. We have an international seed repository where seeds of all sorts of plants and trees are protected, but we have no such fungal spore repository. And I think that especially with climate change and the emphasis on restoration and, this new funding opportunities around restoration, where there's a potential need, there's a definite need for something like a national spore repository. And maybe we could start an effort there. What do you think of that, Thea?
I'm all for all sorts of efforts. That sounds like a great one. More just alpha taxonomic research, more, yeah, I'd say at this point, we need multiple strategies, multiple approaches. And yeah, as I'm seeing now, I finally tuned in so I can somewhat see the comments, to see Biddy's comment that there's a living culture collection. And yeah, that's absolutely part of a toolbox that we need to have going forward. Yeah, the thing is with the living cultures, it's hard to get some species into culture, especially some mycorrhizal species. So that's where we might be talking more about trying to create mycorrhizal refugia or some sort of growing conditions for these trickier species. But again, it's a question of our desire for conservation, which is real and valid and something that we need to be thinking of, running into our lack of concrete knowledge about some of these species and how they work. So that's still a stumbling block, I think.
Absolutely. We know so little about how important fungi are in all ecosystems.
Yeah. Absolutely. Let's see. Just looking back, I see a question about the validity of traditional indigenous burning practices having positive value today in the face of climate change. And yes, absolutely. And that's something that I hope more land management agencies are doing, is paying attention to their local tribes and the knowledge that still exists in these tribal communities. Yes. Traditional ecological knowledge is incredibly important, especially as things are changing more and more rapidly. So yes, listen to your elders and listen to the people who are here first. And these burning practices that have been traditionally held so long over these landscapes, only to be interrupted quite severely in the past century and a half. They may not be the only answers, but certainly it's worth paying attention and trying, because some of these practices can be really helpful in protecting culturally important plants that are also biologically important, and protecting communities, ecological communities that are of both cultural and biological importance.
Well said. Thank you so much, Thea.
You're very welcome.
I do have one more question that popped up, and I think I know the answer to this one. Is there a downside to thinning and slash burns?
Is there a downside?
Yes.
Is there an upside? Yeah. So thinning out a forest and burning a slash in place in piles is, in a lot of cases, necessary because things are so absolutely overgrown. But it's also not the same as having an uninterrupted cycle of burns. Thinning mechanically, especially if biomass is removed from the site, is doing a lot of different things to the mycorrhizal community and to the remaining plants. There's a whole bunch of hormonal signaling that is different from what happens in a fire. So yeah, it's the effects are different between thinning and then burning slash versus just burning. But I don't want to dissuade anybody from, thinking of thinning as a first step, at least, because we're so far out of whack now that in some ways we can't go back. We got to work with what we have now.
Thank you. And as I said, thank you, Thea Chesney, for such an excellent, well thought out presentation. Great answers to really tough questions. And thank you to everybody who watched. And thanks to CMS members for supporting this invited speaker program. And tune in next month on December 15th for Zachary Mozzie, a local who was our first Zoom presenter when he was trapped in Thailand by COVID. And he'll be back talking about his recent trip to Mexico with Alan Rockefeller and talking about Psilocybe species. And Thea, I just wanted to zoom in here a little bit and show you this t-shirt I'm wearing here.
All right.
Yeah. And
looks great.
It is our current design, and we have some left over from our mushroom show, and you're entitled as this month's invited speaker to a t-shirt, so we'll talk offline and how you can
perfect. I'm so there. Lovely.
All righty. Thank you, everybody. Thank you all for tuning in, and tune in next